In section 4.2, we're going to be looking at congruent triangles. So remember, congruent means the same. Before, we've either talked about angle measures or segment lengths. Now we're going to be talking about an entire geometric figure. So in order for two triangles to be congruent, all three angles must match up and all three sides. So there needs to be three pairs of corresponding angles and three pairs of corresponding sides. We write that as triangle ABC is congruent to triangle DEF. So if they are congruent, they are exactly the same size and exactly the same shape, although they may not be drawn in the same orientation on the page. This is a little bit more complicated than we've done before because now the order in which we list the vertices matters. So we need to make sure we write them in the same order so that they match up. So if in triangle ABC, angle A corresponds with D, we need to write A first and D first. If angle B corresponds with angle E, then that comes next, and then C must correspond with angle F. Okay, there's still more than one way to write it, but we have to make sure that they line up. So if B corresponds to E, then we need to write that first. A was corresponding with D, and then we have F left. Okay, or for CAB, that is now FDE. Okay, it will help if you're either marking or using the congruent parts in the diagrams. In our next example, we're going to write a congruent statement for the triangle shown below. We also have to identify all pairs of congruent corresponding parts. That part may be easier to do first, so we're going to list pairs of angles first. Okay, so if we have K, that has one line in the angle, and that corresponds with S. So we know that angle K is congruent to angle S. L has two marks, and so does R, so we know that angle R is congruent to angle L. And then we are left with angle J must be congruent to angle T. So those are our corresponding parts that are angles. We can then list our sides, and these are also helpfully marked for us. So ST and JK correspond. So JK is congruent to J corresponds with T, so we need to write that one first, and then K corresponds to S. Okay, and then we have segment KL is congruent to SR, and segment JL is congruent to TR. Now that we have all of those listed, it will be easier to go back and write our congruent statement for the triangles. So this is going to look like triangle. Let's just go in order KLJ. Doesn't matter which order, but we need to do them in the same corresponding order. So it needs to be SRT. In our next example, we are told that in this case it's not a triangle, but it's still a geometric figure, that quadrilateral DEFG is congruent to SPQR. So I have four colors here, so I'm going to circle D and S. I know those correspond. And then E corresponds to P, and F corresponds to Q, and G corresponds to R. The color coding will help because we need to find the values of X and Y. X appears over here in angle Q, so does Y, and I also know that x appears here. So the first thing I want to do is this expression here has just x. So I know 2x minus 4, and I need to find the corresponding side. So this is between my red and my black vertices, which corresponds to 12 feet over here. So this equals 12. So I'm going to add 4 to both sides, so 2x equals 16, or x equals 8. So there is one of my answers. And then I now need to find y. So I know that 6y plus x is going to be the same as my corner here, which is 68 degrees. So 6y plus x equals 68. But x equals 8, so I'm going to substitute that. Subtract 8 from both sides, so 6y equals 60. So y equals 10. In order to prove that two triangles are congruent, we must use the definition of congruent triangles. So we need to show that the corresponding parts are congruent. So either all three pairs or all three sides are congruent. For example, in order to show that triangle PTS is congruent to triangle RTQ, we need to look at our three sides first, and I have PS and QR that are congruent, and then I have PT and TR that are congruent, and I also have ST and TQ that are congruent. So I have three pairs of corresponding angles. Okay, now I've erased those marks because we can also do the three pairs of angles. So angle P is this angle here. Now we are told with these two symbols here that these lines are parallel. So P, angle P, and angle R are alternate interior angles, so they are congruent. Angle S and angle Q are alternate interior angles, so they are congruent. And then these two angles right here are vertical angles, so they are also congruent. So we have satisfied that all three pairs of sides and all three pairs of corresponding angles are congruent. Now, since we know that all triangles have interior angles that add to be 180 degrees, if we know two angles, we also know the third. So if I can show that for any two triangles, if there are two pairs of congruent angles, then that is sufficient to say that the third angles are also congruent. We're not going to do a proof for this theorem, we're just going to use it. In our first example, we want to use the diagram to find the measure of angle BDN. So we are looking at this angle right here. Now, we know, based on our diagram, that angle A and therefore angle B are both 45 degrees. We know that this angle and this angle are congruent because they're vertical angles. So we know that angle D is whatever is left. So 180 minus 60 minus 45 equals 75 degrees. In our next example, we're told to write a congruence statement, so we'll do that first. So we'll identify our first set of corresponding angles, which I will write first in both triangles. So you can do your setup here. And so it's L in our first triangle and S in the second one. And then N is congruent to R, so I will write those next. N and R. And I am left with M and T. So we now have a congruence statement, and we have to find the value of X. X appears at angle T and nowhere else. So we know the measure of angle T is going to equal the measure of its corresponding angle, which is m, which we also don't know, but we do know that that equals 180 minus 55 minus 65, because that's what's left over when I've accounted for n and l. So in this case, the measure of angle T equals 60 degrees. I can now set that equal to 2x plus 30 and solve for x. So 2x equals 30 and x equals 15. That's what we're told to solve for, so I'm done with that example. In this next example, we are told that RP is congruent to NM, and we are told that Q is the midpoint of RM, which, based on the definition of midpoint, tells me that RQ is congruent to QM. And because Q is also the midpoint of PN, that tells me that PQ is also congruent to QN. So I have 3 pairs of matching sides. We are told that this is 92 degrees and this is 92 degrees. We also know that whatever this angle is, it is congruent to this angle because they are vertical angles, which means our third angle here, angle R, must be congruent to angle M. We have 3 congruent corresponding sides, and we have 3 pairs of corresponding congruent angles, so we have indeed satisfied all the conditions for triangles to be congruent. So the answer is yes, because we have 3 sides in each that are the same, and we have 3 angles in each that are the same. In our final example, we're going to complete this proof. We actually have quite a few givens. So we are told that AB is congruent to BC, that AD is congruent to DC. We are told that angle ABD is congruent to angle CBD, and that angle ADB is congruent to angle CDB. We want to prove that our 2 triangles are congruent. So our first 2 statements in line 1 both appear in my list of givens. So my reason is that those are given. Now, reflexive property of congruence is when something equals itself. In this case, both triangles share this line right here. So we will say that segment BD is congruent to segment BD, and that is the reflexive property of congruence. In statement 3, both of those congruency statements appear in my givens. So again, my reason is just simply that they are given. For line 4, the reason is the third angles theorem, which means that because we already know this set of angles and this set of angles, we must be talking about angle A and angle C. So in order for those to be congruent, we had to use the third angles theorem. And now we can come to our statement that the 2 triangles are congruent because of our definition of congruent triangles.